OK, so the reason we spent all that time talking about key signing keys and zone signing keys is not because we're going to test you on it, but mainly so that we can show you, using the dig utility again, what an actual DNSSEC lookup walkthrough looks like. So again, if you're happy with the conceptual picture we showed, where we said that every name server endorses the next name server using a certificate, you're more than welcome to stop there and just fast forward through this. But just for the curious, let's see what the full lookup walkthrough looks like with key signing keys and zone signing keys. So again, we're using the same old dig utility. We're turning on DNSSEC, and we want to start with the root. And whenever we ask for any DNS query, we start by asking the root name server. That's the hard-coded IP address of the root name server. And over here on this side, we'll also keep track of all of the records that we receive so that we can keep track of what we trust so far. So the only thing in our cache so far is the hard-coded public key of the root name server. The root name server has a public KSK, that's the upper half of the root, and it's hard-coded into everyone's resolver caches, so we trust it. So let's ask the root name server what its public keys are. This is how the top half is going to endorse the lower half. And so the root name server comes back with the same old DNSSEC response. And this time, there's an interesting thing that we notice. Maybe you noticed it when we talked about DNS. Now that we're talking about DNSSEC, we'll call it out again. What's this additional record? I don't see any additional record here. So why is it telling me that there's one additional record? Well, that's this pseudo section right here. Remember we said that for backwards compatibility, there is no space in the DNS header to put flags for DNSSEC. They just don't fit. So any additional flags have to go in an additional record. So all of this stuff in this pseudo section corresponds to that one additional record. So now you know. And we don't get an answer, but we do get the zone signing key of root. So this is the lower half's public key. And we get a signature on the lower half's key. So this is the upper half endorsing the lower half. It's saying, if you trust root KSK, upper half, then we're going to use that to sign root ZSK, lower half. So now you trust root ZSK, which is the lower half of root. Now that we trust root's lower half, we can go to root's lower half and ask about the IP address of our favorite domain. We get an answer back. Most of it is familiar. So these NS records, same. These A records, same. They tell us where the .edu name server is. The only difference is these two records. And even if you have no idea what KSKs and ZSKs are, I think this is something that will look familiar. Whenever we want to delegate trust to the next name server, it's done using a combination of two records. The first record is of type DS, and it says, here is the next name server's public key with a mysterious hash on it. And then the RRSIG record signs the DS record, so these two records together form a certificate. It says, here's the next name server's public key, here's a signature on that public key. Therefore, if you trust me, you trust them now because I have signed their public key. So this is how you delegate trust from the root to the .edu name server. More specifically, we're delegating from the root's lower half to the .edu name server's upper half. So now we can go to the .edu name server. We ask it for its public keys, which is how the top half endorses the lower half. And we get back a similar answer as before. Here is the lower half public key. Here is a signature on the lower half's public key. So if you trusted me, the upper half, now you trust the lower half. And here's my public KSK so that you can verify the signature. So this is the upper half endorsing the lower half again. Then we go to the lower half. We ask it for the IP address of eeks.berkeley.edu. We get back an answer that is exactly the same as normal DNS. We have NS records. We have A records. Those tell us where to go next. No difference there. The only difference is these two records, and these two records endorse the next name server. Anytime you want to endorse the next name server, you send a DS record and an RRSIG, which signs the DS record. And these two together form a signature on the next name server's public key. You trust me, I'm signing their public key. Now you trust that public key as well. Finally, we go to the berkeley.edu name server. We ask for its public keys. Its upper half endorses its lower half using these three records. Same pattern as before. Here's the lower half public key. Here is an RRSIG type record that signs the lower half public key. And here's the upper half public key so that you can verify the signature that was sent. And finally, we ask the berkeley.edu name server for the requested domain and its IP address, and we get back the answer. Here's the answer. eeks.berkeley.edu has IP address 23.185.0.1. That's our answer. And we also get a signature on the answer, and that's how we verify that the record hasn't been tampered with. And if you want to verify all the way back up, you can do so using all of these records that we've collected. How do I know that this eeks.berkeley.edu record is correct? Well, I know that because it was signed by berkeley.edu. How do I know that berkeley.edu's public key is correct? Remember, I used that public key to verify. How do I know that public key is trustworthy? Well, it was endorsed by .edu. They endorsed with a DS record and said, this is the correct berkeley.edu public key. How do I know that the .edu public key was correct? Well, that was endorsed by root. And how do I know that the root's public key is correct? It's hard-coded in all of our resolvers. So all of these records that we cached can be used to verify this record all the way back up. That's the full DNSSEC lookup walkthrough. Again, you don't have to know all of the nitty-gritty details for this class. It does get a little bit confusing once we introduce two different keys. But if you understand the intuition, the idea of combining certificate chains with digital signatures, then you're all set.